We've all seen the electromagnetic force at work, but the most common manifestation of the electromagnetic force, the contact force, operates unseen in every atom of your body. And believe it or not, your very life depends on this unsung hero. To understand the contact force, we need to understand the electrical model of matter. At least as far back as the ancient Greeks, people noticed that everyday matter could be magnetized or create sparks. But we didn't have a very accurate way of explaining that phenomenon until the end of the 18th century, when Benjamin Franklin did all of his experiments with electricity. In the course of his experiments, Franklin hypothesized that matter consisted of two types of charged particles, one which liked to move easily like a fluid, and another which liked to stay put. This idea laid the foundation for the work that led to our current model of the atom, where we have positively charged nuclei surrounded by negatively charged electrons that often flow from one atom to the next, like a fluid. It's easy to appreciate the power of electrons moving through a bolt of lightning. But charged particles have just as much energy at home in their own particles, which brings us back to the contact force. The contact force is the electromagnetic repulsion between the electrons of one atom and the next. Just as the same poles on a magnet repel each other, the negatively charged electrons repel each other, keeping atoms separate. So imagine these are two atoms. The Zorbs represent negatively charged electrons on the outside of the atom, and the guys inside represent the nucleus. Because the electrons on the outside of the atom are both negatively charged, they'll repel each other. That repulsion is what makes atoms seem solid, even though atoms, like these Zorbs, are really mostly empty. And because the contact force makes atoms appear solid, it makes every object appear solid as well. So the electromagnetic force is pretty important. It prevents gravity from condensing everything on the Earth into a little tiny, super dense ball of matter. But let's say you want to walk through walls, so you hire a mad scientist to somehow shut off the contact force in all the atoms in your own body. The problem is, you wouldn't just move through walls, you'd move through the ground too. As soon as your atoms lost their contact force, gravity would pull you down into the center of the Earth. So the contact force as part of the electromagnetic force is kind of a big deal when it comes to, existing. But the contact force can also be used in destructive ways. Anytime that something gets smashed, sliced, or otherwise broken into tiny pieces, you can thank the contact force. Imagine these two lines of Zorbs represent the atoms in two surfaces. The closer these two surfaces get, the stronger this repulsion becomes. If they're pushed together with a force stronger than the bonds holding each surface together, one or both of the surfaces will break apart. That's it for this episode of PS 100, but you'll find more science and research opportunities for undergrads at BYU in the description below.